and drafts in SPSS, we have with us Professor Kishore Bhanushali, who has over 18 years of experience in corporate and academics. He started his academic career at MS University of Baroda, and thereafter he worked with Mahatma Gandhi Labour Institute, Ahmedabad, ICFI Business School, Ahmedabad, and Global Institute of Management, Gandhinagar. His areas of interest include research in the area of disability and rehabilitation, employment, informal sector, and gender. Professor Kishore has many research paper presentations in national and international conferences and a number of edited books into his credit. Sir has been regularly conducting various FTPs in the areas of research methods and data analysis. We welcome you, sir.
Thank you. I'm just setting the background as suggested.
Yes. Over to you. Yes, perfectly audible.
Give me a minute.
Okay, sure.
Am I audible, ma'am?
Yes, sir.
Yeah, thank you, ma'am. So, good evening to all the participants. Thank you, Supinder ma'am, for this nice brief introduction. I'll start by thanking Manav Rachna International Institute of Research Studies and Faculty of Behavioural and Social Science Department of Economics, and also the Department of Applied Psychology and Council for Doctoral Program for giving me this opportunity to share my views and thoughts on the topic that is allocated to me. And sorry for being late because there was a time that was not somewhat convenient to me. I just returned from the office, and just during the discussion, I'll be shipping tea as well.
Sure.
So the topic that is allocated to me are briefly two separate topics. One was reliability analysis, and other is graphical presentations. Of course, both itself are quite wide topic. So I would like to thank Dr. Durairat Swami, and my friend Atman Shah for inviting me for this wonderful workshop on data analysis or data analytics using SPSS from basic to advanced. So I was going through the entire schedule, and really I must appreciate the organizer for the kind of coverage that we had in the program. So the topic starting from fundamental of hypothesis to data analysis and ANOVA, MANOVA, then factor analysis, principal component analysis, ANCOVA. So not many good topics are covered, and anybody who is into research, either as an autonomous research or maybe part of your PhD program or maybe your independent research project that you are into, this is something which is very important for everyone and really need of the day. So I'm sure that those participants are going to benefit a lot. So congratulate Dr. Durairat sir for organizing this wonderful workshop.
Thank you, sir. Thank you for joining.
You had a wonderful interaction. So what I'll do, because since we have very limited time, and then as sir said, we had a discussion over a call that he wants to have some time for the discussion as well. So going by the timing, we have 1 hour, and that 1 hour we have to cover up lot many topics that we have at disposal. So my intention here in that next 1 hour is to give an outline of both the topic, and expecting that somebody who is keen to learn will be able to learn a lot on their own as well, provided you are provided with the background information. So background we'll be discussing. We'll have some time for the discussion point if at all you have anything to be done beyond what we have covered in the class. So let me start with the one topic number one, that is reliability analysis. So when you say reliability analysis, what does it mean? Say suppose normally when we go with the data collections, you might have studied the research process, and the research process data collection is one of the major component that we have. Either you go with the secondary data or you go with the primary data. Now, when you are talking about primary data, through a questionnaire or interview schedule, there is something called measurement. Something that you might have studied, that many of you, as I got to know that you are faculty members and PhD scholars, you may be aware that we have nominal, ordinal, interval, and ratio scale. There are 4 measurement scales available. And if I want to make it quite simple in terms of, suppose we want to measure age as a variable. For age as a variable, we have a measurement tool available. So we measure the age in terms of years. If I want to measure height, I got centimeter and inch. If I want to measure income, I got measurement in terms of rupees. If I want to measure a temperature, I have got Celsius and Fahrenheit. Okay, so for many of those parameters, we have some or this other standardized measurement tool available. Okay, but suppose we want to measure a variable which are abstract, like you are using a particular brand of mobile phone, and I'm conducting a survey about the mobile phone. I want to know how much money you have spent. So I have the measurement available rupees. If I'm interested in knowing the size of the mobile phone, then I have got a measurement available centimeter or inches. I want to find out how much what do you call battery life. So you have some measurement available. But suppose I'm interested in knowing your level of satisfaction. Are you satisfied with the mobile phone or not? Now in that case, I don't have any specific measurement. I cannot measure the satisfaction in terms of rupees or kgs or grams or amount. So those are the variables: satisfaction, motivation, perception. So there are many such variables where there is no standard measurement tool available. Now, when such measurement tools are not available, we as a researcher need to develop our own scale. And there are various methods of scale development. One of the prominent method that we normally use, we call Likert scale. Likert scale, that is 5-point Likert scale. So in context to this mobile example, I can give you a statement that are you satisfied with the color of the mobile phone, the length of the mobile phone, fill of the mobile phone, battery, camera quality, price, discount, availability, weight. So that can be n number of parameters. Now, which parameter do I consider? That depends on my purpose, my objectives. So what I'll do, I'll review a literature, I conduct the preliminary work, and that review of literature and preliminary work will give me a list of the parameters. But ultimately, I want to measure the level of satisfaction. So we measure the satisfaction using various parameters. And we developed a scale, say 5-point Likert scale. So for each of the parameter, I give you a statement, okay, and ask you your agreement, level of agreement. Maybe fully agree, partially agree, neutral, partially disagree, or fully disagree. That becomes a scale. Or maybe it is a satisfaction specific. Then I say fully satisfied, partially satisfied, neutral, partially dissatisfied, and fully dissatisfied. That becomes a scale. So what we did, we have large number of statements. These statements are identified for a variable which are taken from a review of literature and primarily research. So for all those parameters, I got say statements. And those statements together in a Likert scale, that matrix is what is called satisfaction measurement. So what I did, since for the measurement of satisfaction, there is no ready-made measurement available. Measurement available, I need to develop the scale. So Likert scale has been used to measure a satisfaction. So I've got say 10, 12, 15 statement. I think you have a topic on factor analysis. Okay, so when you do a factor analysis, what you do, you are getting factors. And that particular factor is measuring a particular construct. Okay, so that's where the construct are developed. Now you want to check whether the scale that you have developed is reliable or not. Okay, we have two important concepts. I suggest every participant to look into it and make note of it so that you can do a better homework and better reading on the topic wherever you are talking about developing any kind of skill. There is something called reliability and other concept is called validity. So reliability of the scale and validity of the scale. Here we are talking about reliability. Now when you say reliability of the scale, it means you are interested in knowing that I have developed a scale. Now whether scale is reliable or not, it means whether the scale is actually measuring the construct that I want to measure. Okay, now it means if scale is reliable, it means the scale is actually measuring satisfaction, which actually was my interest. Okay, so in order to check whether the scale is reliable or not, there is a scale test which is called reliability test. Okay, and the most prominent used reliability scale is called Cronbatch alpha. Cronbatch alpha. Okay, so before we proceed with Cronbatch alpha, I can share my screen to guide you in terms of how the scale, the testing basically takes place and how do we interpret the result. Any question with anybody at this stage, feel free. Anybody? Yeah. You can put something in the chat box as well if you feel like. I'm looking at the chat box also. Feel free. Or should we continue? You can have.
Yes, sir.
Yeah, thank you. So let me share my screen. Is screen visible?
Yes,
Yes,
sir,
sir, it's visible.
Thank you. This is the file which I already shared, and just to give a background, this is a sample file. So those who have installed SPSS in the system, when you download and install SPSS, it gives you a sample data file also. So this is the one of the sample data file, and remember the name. This is a file which is named as employee data. Most something that I like most because I have been using it since long. This is an employee data file, and what I did is I have added Likert kind of questions. So I've added couple of statements. So this S1 to S1.1 to S2.5, these are the additional variable which I have added. No logic, no, this is a dummy data you can count. Now what does it say? To give you a background of the file, because we'll be using the same file for the data analysis also. So what we have in the file, this file has a data about an employee for a multinational company. What data has been collected? So data is related to ID, so employee code, then gender, coded as male and female. Then we have B date, indicates date of birth. We have EDUC variable called education level. Job cat indicates employment categories, and employees are categorized into clerical, custodial, and management. Assuming that you know how data entry works and all those things, so not getting into that detail. If you have any clarification, feel free. We don't mind going back to the theoretical part. There is a variable called salary, which indicates current salary. Variable called sal begin is called beginning salary. Job time indicate months since hire. It means since how many months you are working with this company. Previous experience in terms of number of months. What is your previous experience? Minority, it means minority class, because it's an American company. So all Americans are non-minority, non-Americans are minority. So there's a variable called yes, no. So if I say I'm non-minority, it means I'm an American. If I say I'm minority, it means I'm non-American. That's how the hypothetical variable has been created. Now what I did is I have added a variable here, satisfaction. Satisfaction. So here the satisfaction, I have developed certain parameters. So satisfaction with reference to salary, okay, incentive, bonus, increment, and advances and loans. So these 5 variables are added. So there was a statement against each of the variables. So your salary is reasonably good, incentives are available in time, okay, and for each of the parameter, 5 points scale has been developed. 6 is no answer, but I have not captured that. So strongly disagree to strongly agree. And so these 5 parameters are related to financial aspect. So one, satisfaction with reference to finance. So financial variable is one group which has 5 statements or 5 sub variables. Then others variable is another group, job time, canteen and food, transportation and travel, office arrangement like facilities, and administrative support like including agent. So this becomes in office or maybe facilities kind of variable. So I got 2 variables, salary, that is a financial aspect, and other is non-financial aspect. Assuming that my satisfaction with reference to my job depends on financial variable and also non-financial variable. Among financial variable, we have salary, incentive, bonus, increment, all those things. So I got 5 variables which are measuring satisfaction with reference to financial variables. And other is non-financial construct. Now, I have got this variable, so statement 1.1, 1.2, 1. These are names that are given. So 1.1 to 1.5 are related to finance, and 2.1 to 2.5 are related to non-finance. Okay, so statements are designed, data are collected, and data entry has been done for all the variables. So entry is available here. Now I want to check whether my scale is reliable or not. Okay, so we'll run a reliability test. So I've got 2 scales, one for finance, one for non-finance. And I want to check whether scale is reliable or not. Okay, so how does it work? In the presentation that I've already, PPT I've already shared, the steps are also mentioned. And still, you can focus here and we'll want to do it again. So we have menu called analyze. In analyze menu, there is a variable called scale, and this is reliability analysis. Okay, so analyze, scale, and reliability analysis. So we click on this reliability analysis, and we get a box. In our terminologies, we call it dialog box. Dialog box means you are given a command to software that do reliability analysis. Software enters into a dialog with you saying that for which variable you want to create or you want to do a reliability analysis. So we go down and select our variable for analysis. So my first group of variable is financial part. So I select those 5 statements which are measuring one construct. So select, getting this on this side. So select it. So one command that I given is run a reliability analysis for this 5 statement, which is a one group financial factor or factor finance. You click on the statistics. Okay, primarily we work on the scale. Scale if item is deleted, and then click on correlation. Okay, you can also click on main. So once you select, they'll give you everything. But since beginning, we focus only on those few selected options which are more relevant to us. Once you have hands-on practice with this, you can very well root the theory and get into other options as well. So I've clicked on scale. Scale if item is deleted, correlation and mean. Okay. Then pressing continue and pressing OK for this site. Okay. I hope a screen is still visible. There is no disturbance.
Yes, yes. Output file is visible.
Yeah. Since I've shared the entire screen, I think it will be more easy. So what we have, one is case processing summary. So this says total 474 cases are there. So total respondent that are included in the survey is 474, and all 474 are included. There is no excluded. Now here the exclusion comes in if any of the respondent has not answered any of the statement. So if there are missing number, softwares exclude those cases. So make sure that all answers are properly captured, and only those respondents are considered who have responded to all the statements. Then we have, this is called reliability statistics, and this is the most important value that we have, that is called Cronbach's alpha. Here Cronbach alpha is 0.844, so it is 0.08. Standard benchmark that we have, we consider is anything above 0.7, 7 and above is accepted. Below 7, up to 0.6, you can, but it is your personal choice. That scale is still not reliable, but still, if you want, you can consider this. 5 and below, or rather 6.5 and below, we do not use it. We say scale is not reliable. You need to rework on the scale. Now, what happens, and my own experience says, respondent or individual comes to us after the data collection is over. We run this analysis, and they say your scale is not reliable. So, what to do now? Now, if your data collection is over, scale is not reliable. Okay, you don't have any choice but to accept the fact that scale is not reliable, and there are certain analysis tool, parametric tools, which you cannot use, number one, or you need to add other data, or you need to recollect the data again. So advisable is, as you start your data collections, before collecting the actual data, you need to run a pilot testing. So run the reliability statistics for pilot data itself, pilot testing, and check whether the scale is reliable or not. If the scale is not reliable, it means you need to make correction in the statement. Something is wrong with the statement, the way you have framed. So you need to rework on the questionnaire itself, and then come out with a new scale before getting into a detailed data collection. Otherwise, you will be in trouble at a later stage. Okay. So here our scale is 0.844. So we consider the scale to be every item is correlated with other item. It's salary and salary correlation, salary with incentive, salary with bonus, salary with increment, salary with advances. Now look at the number in totality. Most of the variables are highly correlated with each other. Is there in same construct, financial aspect? If they are not correlated, your reliability analysis will not give you accurate result. So in a reliability analysis, check this inter-item correlation and give you one value for that inter-item correlation. Okay. Now here, if you look at, there is a variable called increment. All other variables are reasonably good correlated, but increment is having very low correlation with other items. So increment with salary 0.39, increment incentive 33927. Okay, but still correlation is positive. Okay, that's where we are getting a Cronbach alpha, a positive one, and reasonably good amount. So this is something which need to be looked in. If there is some negative correlation between two variables, it means the way you have framed the statement is wrong. Okay, somebody agreeing with the statement, it disagreeing with the other statement. Since both the statements are measuring the same constraint, same construct, their responses are supposed to move in the same direction. Responses cannot go in the opposite directions. So if there is negative correlation, any value here, you need to rethink and check the statement again. If some variable is not at all correlated with any other variable, or correlation is very less, okay, it means that variable is not significantly contributing, and rather you can think of deleting that variable. Shall we take all data to check the reliability, sir? Okay, Mr. Balakrishnan will come to that point. Okay, let's complete this first. Okay, so this is one. So this is for inter-item correlation, and then gives you a summary statistics that average mean score is 2.77, the minimum, because we have created a 5-point scale. Okay, 5-point scale. So average is 2.73. So most of the responses lies in the middle. Minimum 2, maximum 3. Ranges minimum minus. So these are descriptive statistics for these 5 items. What is important for you is this table. Salary. Okay, and look at this. Scale Cronbach alpha if item is deleted, the last column. So if say, if you delete salary, then Cronbach alpha will decline, because as of now our Cronbach alpha value is 0.844. So if you ignore or delete that salary statement, that salary one variable, your Cronbach alpha will decline. Incentive, again Cronbach alpha will decline. Bonus, again it will decline to 8.4. Increment, it's a 0.877. Loans and advances 0.88. So what we normally do is we compare this column Cronbach's alpha if item is deleted with our Cronbach alpha 0.884. Sometimes it happens that this value is 0.7 or 0.6. But when you look at this Cronbach alpha if item is deleted, you realize that there are some value which need to be deleted. Okay, which need to be deleted. So here, suppose I delete increment, because if I look at this inter-item correlation, increment is not significantly correlated with any of the variables. Okay, so when it is not going with the other variables of the group. So if I delete this, there are likely chance that my Cronbach alpha from 0.84 it will go to 0.87. Okay, now whether I should delete or not, that is an individual choice. That depends on importance of this variable. Now here, without deleting this, if my scale is reliable, why I should delete? So I'll continue with increment as a variable. Okay, this is how it works. Now let's see again the same analysis for the second variable, and then I'll be answering the question which we have in the chat box, okay, during our discussions. So again, I'm going to analyze, scale, reliability analysis, and now instead of finance, I'm looking at the variable here, job time, this non-finance, and statistics. Again, I continue the same, and okay. Again, my Cronbach alpha is 0.824, which is good to go. Any Cronbach alpha value 0.7 and above, your scale is reliable. 0.6 and below, not reliable. Between 6 and 7, you can take up a call. Here again, inter-item correlation is reasonably good. Minimum, maximum, and see here, the Cronbach alpha with all 5 statement is 8.24. And if I think of deleting any of the statement, my Cronbach alpha will not go up. So it's advisable to continue with all the variables. So my scale for measuring financial construct is reliable. Non-financial construct is also reliable. Now suppose, and this is something which researchers have done rather than error. Okay, when you do factor analysis, you will get to know this variable. Factor analysis will tell you that this is one group of factor. And after running that factor analysis, you will get the group of statement. And for those group, you can run this reliability analysis. But suppose I do with all the variable together. So I'm not working with this group only, but all 10 together. Okay, and run the same analysis. What comes in? Look, what is my Cronbach alpha? 0.478. It means my scale is not reliable because I have combined both the construct, finance plus non-finance. Okay, so my scale is not reliable, and the reason comes in when you look at the inter-item correlation. There are negative correlations. Okay, so financial and non-financial items are negatively correlated. So somebody agreeing to a financial aspect disagree to a non-financial aspect as well. So since inter-item correlation is negative, my scale is not reliable. And if I look at the Cronbach alpha item is deleted, any of this item deleting will not serve the purpose, because irrespective of the item that you delete, your Cronbach alpha continues to be less than 5 rather. So scale is not reliable. Okay, because what you did, you have mixed two construct, finance and non-finance. Ideally, both are different, so they are supposed to be treated differently. Okay, so this is what our reliability analysis as of now for us. Okay, so let me go to a chat box. Sir, on what point we reject or accept the reliability? So, Indu Malhotra, yeah. So, it is 0.7. So, consider 0.7 as a benchmark. If your Cronbach alpha is more than 0.7, 7 and above, it is acceptable. Otherwise, not acceptable. But do not wait till last. Run the Cronbach alpha on the pilot testing data itself. Okay, that is important. Sir, we take all data to check the reliability, sir. Okay, Mr. Balakrishnan, so we have done it, that exercise here. When you use all the data, unless you know what construct you have. So it has to be very clear that you have developed 5-point Likert scale, one scale for financial aspect. So for financial incentive, you have one value. So that is a separate construct. So that is a separate reliability test. For non-finance, you have another one. So both need to be done separately. Yeah, standardized item, Anita, of course, we had a constraint of time. So this standardized items is normally, you know, the standardized scale, okay, as that Z value, but most of the time it will not have much difference. So most of the time we'll use Cronbach alpha, non-standardized only, okay. If scale is reliable on pilot study, will that be reliable on complete study as well? Do we need to run the test again? Yes, Kanika. If it is reliable on the pilot testing, it has to be reliable on the final data as well. But what my experience is, it all depends on the way data have been collected. Normally in research, we say, specifically analysis, we say garbage in, garbage out. Normally when we create the scale, when we collect the data, we have the statement. And then people are not reading the statement, they simply tick mark. So when the statements are answered without giving a detailed thought to it, okay, you may not get accurate results. So for accurate result, even after the scale is and remember there are subjects where ready-made scales are also available, which are tested already for reliability, validity. But then those scales are developed in a different location, different time, different group, may not be applicable to you. So reliability questions comes in. When you are collecting that data, make sure the respondent is reading the data, reading the statement, and they are answering. Okay. So has to be taken care of. I hope you answered the questions, Kunika. Kunika,
yes, sir. Yes, sir. Thank you so much, sir.
Sure.
Got the point.
Should we go ahead? Any other question with anybody before we move on to, because we have some time for the graphical part? Okay, so make sure that you do it, and reliability analysis is something which needs to be taken care of. Normally what we do, we had series of the statements. I have got 60, 70 statement. Okay, I run factor analysis first. I get the factor. For each factor, I run reliability test. Okay, and that's what the principal component analysis does. And if you have confirmatory factor analysis, you know that okay, factor is there with me. You can straight away run the reliability test and check whether the scale is reliable or not. But remember, as and when you are talking of the variable which are for which no standard measurement is available, you are developing a scale. Okay, you need to check whether the scale is reliable or not. Without checking the reliability, you cannot go with the further analysis. Anybody will put a question mark on your analysis. And yeah. So next topic we have is hold on for a minute. Yeah. Okay, Kunika is asking in which case we can pick the standard scale for our study. Kunika, that depends on the topic and subject, because there are people, there are agencies which are specialized in developing a scale. Say in HR, there are many topics for which standardized scales are available, but then you need to purchase those scale and you should know the keys, how those scales need to be analyzed. In psychology, specifically, there are standardized scales available. In HR, there are standardized scales available. Now, a couple of scales are being available in the area of marketing also. But when you use the standardized scale, you need to purchase those many number of copies, and along with those standardized scale, you should know the key that you are going to use it for the purpose of analysis. Okay. So has to be used carefully. And secondly, when you purchase the standardized scale, you need to check whether the scale has been developed in Indian context or not. So most of the time, what I guide the scholar is, you pick up a ready-made scale, and when you do a literature review, you'll get to know that what scale other people have used. So if there is a scale which is most widely used, you can use that scale as well, but try to customize it as per your requirement. So you have a scale available, okay, and you need to customize as per your requirement, your location, and then run the reliability test as well. Okay. So now going ahead with the
Excuse me, sir.
yeah.
Sir, if we customize the scale, will it be called the self-structured questionnaire, or will we say that it is the standard scale that we have picked up?
No, questionnaire is different. Questionnaire include everything. Scale is one part of a questionnaire. Okay.
Okay.
Standardized is something which is already used, prominently proved effective. That is a standardized one. But when you are customizing it in your methodology, you can specify that we have used this scale, but customized as per the requirement, and you should be very clear in terms of what changes have you done.
Okay, sir. Okay. Got
Okay.
it.
So that
Thank you so
clarity in methodology has to be defined, so nobody can challenge it.
Okay. Thank you, sir.
Okay. Yeah. So next topic at our disposal, 20 minutes that we have, we are going to talk about graphs. Friends, yeah, Deepak.
So in reliability analysis, there is one option of model.
Okay.
Here we have selected alpha. What are the other models signifies it?
No. Cronbatch alpha is one of the reliability tool. There are other reliability tools also other than Cronbatch alpha. So if you look at this alpha, these are split half, Gutman scale, parallel scale, strict parallel. So there are other options available. Okay, but then most prominently uses Cronbatch alpha. So we'll go with Cronbatch alpha. Once you are hands-on practice, you can look into these other scales as well. But at this stage, advices click on this alpha, leave it as it is, and use Cronbatch alpha.
But sir, in the latest version, we are having the options of ratings also.
Which one?
After the items, when we select the items now, then we are having one more option of ratings. Not in this one, sir, statistics.
Okay, yeah. No, rating, see, rating comes in if I want to rate an item, or maybe I have got a certain number of items. I want to give more weightage to some item. So I've got 5 statements, but salary is more important. So I want to give certain more weightage to that particular item. Those options are available as you when new and new versions are coming up. Those options are getting developed.
Thank you.
Okay. I would love, otherwise we could have a full-fledged session on Cronbatch alpha. Okay, full 2-3 hours, then we could have discussed lot many things. But again, time is a constraint at this stage for us. Okay, but still we can have the discussion after the session as well. So now we are talking about another one called graphical presentations. Initially, when I have started using SPSS, and there were graphs available, as and when you do analysis, you always have a graph. Okay, say for example, frequency analysis. So I want to find out frequency, do a frequency analysis for gender. So what I do, I'll go to analyze descriptive statistics, frequency. Then I select a gender, and here there is an option called chart. If I click on pie chart, I'll get a pie chart as well. Okay, so these kind of charts are available. Okay, similarly, you can have bar chart as well. But when actually I have started initial phase, what I normally used to do, I used to copy this table, take it to Excel, and then create a chart there, because we are more comfortable with Excel in terms of creating graphs and those other functions available in terms of changing the colors and all those things. Okay, but after using SPSS for graph, I realized it is an exceptionally good tool that we have, which can be used before actually you start analyzing the data. Because before you analyze the data, get deeper into data analysis, you are interested in knowing the characteristic of our responses that we have. Okay, the kind of hypothesis you can frame later on. So it is a very good tool for further data analysis also. Secondly, if you are given this raw data in Excel format, you cannot create any chart. Of course, you can use pivot table where pivot charts are there. But that way, SPSS is much better tool in terms of graphical analysis. There are certain graphs which are quite easy to be done in SPSS. Of course, there's an individual choices as well, but much faster, much quicker, much reliable, and much professionally designed graphs, which are most widely used in a research paper, which otherwise are published in Scopus and Web of Science and ABCD journals. They are using this graph as well. And in research, we something called APA style. So every journal have their own style. Somebody follow pure APA. Somebody have some journals have their own style in terms of size of the graphs and design and colors. So those other features are also available in SPSS with reference to graphic representations. Say in simple SPSS, one way of creating graph. One way of creating graph is along with your regular analysis. So here, suppose I want to find out in job category how many male manager, female, manager, clerical, custodial. I can have pie chart as well. So I'll go to analyze, run a frequency. So when I'm running a frequency, itself gives me as an option of creating frequency chart, and I can create a chart as well. So you can click it, it will give me a chart along with the table as well. So along with frequency table, I'm also getting chart. Or maybe suppose I'm interested in knowing how many male managers. So manager, within that I'm interested in knowing breakup of male and female. Among the clerk, breakup of male and female. In that case, when you do a cross tabulation, so analyze, assuming this is you have covered, so I'm going with fast. Cross tab, so I've selected gender, selected another variable, and here there's an option at the bottom left side, cluster bar chart. Cluster bar chart. And along with this cross tabulation, you have statistic, you can have chi-square as well. So along with chi-square and cross tabulation, if I need graph, I can click on this display clustered bar chart and then pressing OK. I got this table, I got chi-square table at the same time. I got chart as well. So this is one way of getting chart in SPSS. But this is not the only way. Better option available in SPSS is in option here called graph. In that option, there are two important things, and you can choose one that you like, you are comfortable with. Both gives the same answer. One is chart builder and other is legacy dialog. Okay, suppose I am using this chart builder. So this is something that I like most, chart builder. So click on chart builder. Okay, your chart builder comes in. Okay, I hope it's visible. Some confirmation? Anika?
Yes, sir, it's visible.
Yeah, thank you. So this is a gallery. Now in gallery, this is a bar chart. So within bar chart, these are all options available. If I click on line chart, these options are available. Area chart, pie chart, scatter plot, histogram, high-low, box, dual axis. These are all chart options are available in gallery. So first thing you do, you need to decide what kind of chart you want to create. Okay, so prominently we use three kind of chart: pie chart, bar chart, and line chart. Now each of the chart has a specific purpose. When you're talking about single category variable, say I got variable gender, I know that it is a category variable because it has two categories, male and female. I want a chart. So for single category variable, chart has to be pie chart. Because out of 100%, I want a breakup. Bar chart is for comparison. So when there's a question of comparison, you use bar chart. Line graph for two reasons. One, if you are comparing a mean value of precisely when you are having the data over a period of time. There's a time series kind of data, most probably used the line graph. And there are scatter plot for correlation to continuous variable. So you have to be very clear what chart you need and for what purpose. Yeah, Indu Malhotra, you can unmute yourself.
Sir, I just want to know from where you have taken this chart builder.
Yeah.
From analyze, from which part have you taken this chart builder, sir?
No, in a graph. In graph, there is called chart builder.
Okay, right, sir.
Okay. So now suppose I selected that I want a chart somewhat variable called employment category, which tells me manager, custodial, like supervisor and clerical. So there is one category variable. I want a pie chart. Okay. So I first select pie chart. I got this pie chart available. My role is I will drag it up to the gallery here. I'm doing it again for the convenience purpose. Reset. I selected a pie chart. Okay. So when I select a pie chart, it gives me a pie chart option. I can drag it up to the gallery. So I got pie chart. Now I need to select. These are element property which can be kept aside. I want to select a variable. What is it? Slice by. So there are 3 slices as of now. You want a slice by which? So select the variable. So I said I want a slice by employment category. So drag the variable here. Doing nothing at this stage. Okay. Here is a count. So here in the property, edit properties of, here's a count. If I want a percentage, I can go with a percentage. If I say count, it means number. This is a percentage, or maybe value, or maybe sum. So we'll go with a percentage. And apply. Here I am saying, so look at this. This will automatically become percentage and pressing OK. Now my chart is ready. Okay. Now this is a simple kind of chart. Many of you may not be comfortable with this chart because there is no title. I want this category to be specified here. I want percentage to be here. I don't like this color. I want to change the color. I want to put some table number, chart number, or maybe some title. So those things are possible under what you call editor window. You need to edit the chart. One, you could have done some editing here. Here, say title. So when you put the title, it gives you a title as well. But normally that is not the simple way. Simple way is this one. So you select the chart and simply double click it. What happens? You have new window. Okay, this is window title is chart editor. So chart editor is available to you. Okay, whatever edit you will make automatically will get reflected into your main chart on the output file. So we expand this. This is a chart editor, and there are options available here. Okay, this option may differ. Some options are disabled because those options are not applicable for this chart. Some options are applicable in bar graph, some are available in line graph. Okay, so this is what a chart editor is. Yeah, Indu?
Again, so where is chart editor? Which column?
No. Just double click on the chart.
So I'm in the chart, sir. Then what next?
Yeah, so we got this chart. You got this kind of table. Or else what you do is.
So I get file and view. Yes, sir. I got the view.
No. Can you? This is a kind of screen that you have.
No, sir. I only have the last screen. The output screen.
Okay, just a minute. So you have this screen as such?
Yes, sir. Yes, sir.
So you double click on this. Double click on the chart. You'll have chart editor. Or else right click and say edit content in separate window. So I'll right click here.
Yes, sir.
Edit content.
And I got this chart editor. Yes, sir. I got chart editor.
Yeah. So this is chart editor. Now there are certain options which are enable, certain options disable. That depends on the kind of chart that you are working with. So here we want to have something called a number here, or I want to have a title first, chart title. So this is a button, insert title. So click and you have titles available here. So I can put the title here. Classification by job. Sorry. Classification by job category. category. Okay, so this is my title. Every time it gives you a property window also if you want to do something. So my title is added. So this is a title bar. Second, I want some footnote at the bottom of the chart. So this is a footnote. Insert footnote. So I can insert a footnote. So the footnote is created. Suppose this chart. So I want to add a footnote, say source, primary data, or whatever source that I have. I can mention this source also. Again, click. So I got footnote here. I want this number something to be here. Okay. So there is another tab here. So data label. Labels are not mentioned. I want to see the data label also. So click on the data label. Label comes in. So now 76%, 17%, and 5%. Now along with 76.58, I want that it should have the clerical. The label should also be mentioned. So when you look at the property side, displayed only percentage. I also want to display employment category. Select employment category. Take it upward.
Sir,
Along with this, yeah.
sir, how did you get the data labels?
Okay. This one. Okay, let me go back. Okay, this is there. Here we have this tab, show data label. Click on this tab, show data label. Automatically table label comes in. But here what mentioned is, what is displayed is only percentage. I want employment category, so I'll select this and say employment category. And then if I apply, it shows both. I can close it up. Now this gives me custodial, manager, clerical also. Okay. Now when this clerical, custodial, manager, this information is available here, I do not want this information here. This is called legend. I don't want legend because colors automatically signifies. So I want to do away with this legend. Okay. So here there is step A, B. Now there's an option called hide the legend. So once I click this, legend is hidden. Okay, my table is ready, my graph is ready. Then suppose I want to change the color. I don't want this to be blue. So I double click on this. Now look, this entire yellow border. Again, one click here. Now this yellow border, so this blue color is selected. Bluish color is selected. And in my properties, it gives me that bluish color. There are two things. One, fill, and other is border. So fill means this entire color and border is this border. Currently, fill is this blue, border is black. I can change. So I want it to be filled not by blue, but I want say light blue, or maybe a light green, or maybe I want it to be white. Okay, but along with certain pattern. So I click on the pattern, it gives me pattern. So I want it to be something like this, or maybe I want it to be something like this. These are all pattern options available to us. So fill with the white, continue border black, but I want a pattern. And then I apply. The color has been changed. Similarly, if I want to go with this, okay, this color is selected, double click, you get to property. Every time you double click, you will get to the property. I want this to be a different color, different pattern. Apply. I can change. Similarly, for this, I want again a different color. So I said, let me give it some other color, maybe some other pattern, apply. I can do this. So these all options are possible within this, number one. Secondly, when you are sending your paper for a good quality journal, there are journal which tells you a size of the graph, size of the chart. Those options are also available in the property, chart size, height and weight. So you can customize chart height weight from here as well. Plus, this is depth and angle. It shows you want a flat chart, you want a 3D, you want a shadow. So if you set 3D, it gives you a viewpoint also. So you can play with this a kind of chart as well. And then if you apply, it gives you a 3D view. Okay, this is what SPSS can do. Excel has those options, but not this much of options are available in Excel. If you want to take away a part of it, okay, if you want to take away part of it, if you click on this, explode slides, slides are different. This is also possible. Okay, but believe me, friends, this is something which you need to practice. You need to learn. Suppose I have got this title bar. I want to change the color. So simply I click on the title bar. I got the color. It is currently not filled. If I want it to be filled by certain color, I can fill it like this. Okay, so it's filled. Okay, so those are the options. Text layout. If you want to be these are the text layout. Currently is horizontal. I can make it top down or maybe bottom up. Apply. This is this layout. Sorry, these are title layout because we have selected title here. Sorry for that. This one. Okay, I can change the layout. So here text layout is bottom up. Look, got change. Text style. What kind of font you need? You can change the font. These are all fonts available. Normally we say Times New Roman. Font size, style. Okay, this is something which you can explore in terms of analyzing a pie chart. That is something which is one thing. As such, as I said, we'll be running short of time. Of course, it's 7:30. So let me show you one more type of chart which is more relevant to you. Okay. Similarly, graph chart builder, I can have something called, say, scatter plot. Assume scatter plot. Others also you can explore it. Scatter plot, and I've selected the second option, dragging it to here. Now it tells me what you are measuring on x-axis, what you want to measure on y-axis. So on axis, I said current salary, y-axis beginning salary, and this different colors of dot, I want you to be representing something, and that something for me is the employment category. So set the color here. Simply pressing OK. It gives me margin. Now look, these are all clerk. This blue one are clerical. So most of them are in the range. So this is a scatter plot. So salary, beginning salary and current salary are positively related, but very highly correlated at this stage. As you go on increasing the salary, the deviation increases. This blue line indicate the clerical group. This green one is indicating custodial, and this one is indicating manager. Similarly, if you double click, you can customize this as per your requirement. Now look at this. For this axis are enabled. Many of those other options are enabled here. Okay, I can create a fit line. I can add fit line at the total, interpolation line. Okay, so within this, we'll simply click and you have the line available, and you know that okay, the R square, this regression coefficient that you have something did. So those are options which can be explored. Third type of chart, graph, most widely used, is, let me reset this, bar chart. Simply I click a bar chart, so dragging a bar here, and I have got say employment category here. I got it. Now what bar is indicating? The count. But instead of that, I'm interested in knowing average salary of these three groups. So I take salary here. What does it give me? Mean salary here. Mean, median, mode. So say mean salary here. And then I click OK. I'll get average salary graph. If I double click and just add the label. Okay. Sorry, something went wrong. Let me correct it. Okay, I'm pressing the data source. What does it give me? Straight away, without doing much of the analysis, it tells me that average salary of manager is 63,000, custodial 30,000, clerical 27,000. Again, I can change the color, I can change the border, and all those other options are also available and possible. Okay. Of course, we are running short of time. There's a question from Shivani. When we have to use scatter diagram. Shivani, scatter diagram is to be used when you are talking about two continuous variables and you want to check whether these two are moving in this direction or not. Say, for example, I have got salary and education. Scatter diagram will tell me that whether with increase in education, salary goes up or not. So scatter diagram is nothing, a graphical presentation of a correlation. Scatter diagram will tell me whether these two variables are positively related or negatively related. Okay, the kind of scatter diagram just we had, we got positive correlation between these two variables. Okay, it is 7:30. I hope I could have captured, cover many more things, but of course, running short of time as per the schedule. Okay, now just to, before we close it up and open for discussion, in graph, there is another called legacy dialog. The same kind of graphs or options are available here. Here bar chart, line graph. So if I go with pie chart here, okay, it will, I need to define which variable. So I said I want pie chart by employment category, and then pressing OK. The same procedure, the same graph. Okay, so both gives you the same kind of graph, but approach is slightly a different approach. So these are all options available. Yeah, histogram, normally we say normality curve. So in histogram, if I want to find out whether the current salary is normally distributed or not, if I click a variable, display normal curve, and simply pressing will tell me this is an histogram for salary and there's a normal curve, which indicates that salary is not normally distributed. Okay, so those options, and there are many more such options available, but paucity of time, we cannot cover up many of those things. Still, if you want, we can have some discussion on any of the topic related to this question that you may have. Feel free. Sorry, sir, I'm extending the time a bit. Yeah, stop sharing. I'm back.
Thank you, Professor Kushar. Am I audible?
Yeah, perfectly.
Yes, sir.
Yeah. Thank you. There is a lot of technical issues at my home. Internet frequently disrupting. So I'm actually using three devices somehow. One or the other way, which device, whatever works, I thought of shifting it. I first of all thank you so much for putting your effort, reaching home at 6:30, and immediately you started the session. And I understand how much effort that you put, and I also see the intensity of your presentation. It's very enriching, and I hope all the participants also received the same. And yesterday there was a concern that some of the participants raised. They